Ah, welcome everybody to the American Space Museum. I'm Marquette, and these are the dog days of summer. And you're going to learn about that on Stay Curious today. Thank you for being with us. Hope you got a cool drink next to you. Got my NASA fan feeling cool here. Marty Winkle, my co-producer over there. He's staying cool. How you doing today, Marty?
I'm doing good, Mark. How are you? You look nice and cool.
Well, thank you, thank you. Let me get my clothes straightened up here so I can look a little more presentable. Got my like I said, my peach iced tea here, my NASA fan. I'm not going to get far away from this. As we know, it's been a hot summer, and we got a reason that they call it Dog Days of Summer. We're going to talk about what's happening right now. 54 years ago, Apollo 11 started orbiting the moon. Hope you've been watching it on Apollo Real Time. And we're going to look at the sky tonight. But you have to look quickly because 3 planets are visible, but they'll be gone by 8:30. So get out there and you're going to see Mars, Venus, and even Mercury if you get a chance to see that. But and it's a hot time on the sun right now. We're going to tell you a little bit about some of the activity going on the sun, and the solar cycles increased big time, and how we can see the backside of the sun with the help of a Mars rover. So stay curious about all that. Let me get my paraphernalia off here. I do look pretty good in that hat, though, don't I, Marty? And these hats we have on sale at our gift shop that Anita Truex has done a good job of handling. That's got a rocket launch on there underneath there. So, but the heat's nothing to fool with, and they are here, the dog days of summer, all right? So learn a little bit about it here. Tell your friends to watch us on YouTube, and also book your trip here to the American Space Museum, as we, for over 2 decades, have been preserving the birth of the American space age right here in this delivery room, Brevard County, Florida. And no more important day of the year than July 20th. Wish it was a national holiday, but that's tomorrow. And 54 years ago, Neil and Buzz landed on the moon with Mike Collins, of course, orbiting. And we're going to talk a little bit about that here in just a second. But oh my gosh, has it been hot everywhere around the world. Breaking temperatures. Of course, you hear a lot about the global climate change associated with this, which is true. But there's also a lot of natural phenomenon that goes on. And would you believe it, Marty, that during the summertime in the northern hemisphere, we are farthest from the sun, about 97 million miles away, as opposed to the average of 93 million miles away. It is during January that we are closest to the sun, about 91 million miles away. So why is the northern hemisphere hot? Because we're tilted away. It all has to do with the tilt of the earth and that globe that you saw on your teacher's desk all those years in elementary school, tilted for a reason. We're leaning into the hot rays of summer where we're at in our orbit around the sun, and the tilt is, and so thus it's very hot. As I've explained over and over, you don't get a suntan from 10 to 11 in the morning. The rays aren't hot enough, nor can you get a suntan from 5 to 6 in the afternoon. The rays are at too much of an angle. When they're directly overhead, that's when it's hot, beating down on you. So we're going to learn a few tips about that, but seriously, I want you all to go to Apollo in real time. Here's a screen grab when the boys went into lunar orbit for the 54th time. And 1969, boy, as it whizzed by. And Marty, got to point out that he was working on LM5 and all the lunar modules for Grumman. Marty, do you have any thoughts about 54 years ago as you see the replay of these things?
I guess I have thoughts. I could just think back on what it was like watching the landing, and obviously the liftoff from the Earth and from the moon.
Right.
Yeah.
Of course, that important liftoff from the moon. Marty had something to do with that. There's a guillotine that slices all of the wires and some tubing, and we're going to talk about that tomorrow on Stay Curious and get Marty to talk more about his role. And the Grumman people have kept together in reunions over the years. They just had their last one, kind of bittersweet. But I have Marty and his friend Roger Vizioli are going to talk to our astronomy club in Melbourne tonight and share their experience. So we're not broadcasting that, but I'll share you some of that, pictures of that evening, maybe tonight's evening. So go to Apollo 11 real time. They also do Apollo 13 in real time and Apollo 17. Maybe they'll put up the other ones, whoever they are, the people that have done this. It's quite interesting as the current events are going on right now. You see the video that they took of the moon rising and pictures that they took of the craters below them. Of course, these were not seen for days after they returned from the moon. There was very little live television broadcast. They did a few shows on there. But you can tell I'm jazzed about it. I always love to watch it. It's some good background noise. But this right now, they're orbiting the moon. They'll take a nap, and then tomorrow in the afternoon, Eagle will depart from Columbia, and the landing's about 5:30 Eastern Standard Time. Tomorrow, which would have been Sunday in 1969. The moonwalk then occurs about 11:30 on tomorrow night. So hope you can catch some of that. Well, like we said, hot, hot, hot out there. So hot that there's a lot of terms for it out there that some we can't say on air. But the heat wave has been all over America. There's the screen grab from yesterday's temperatures in Las Vegas, Death Valley in Phoenix. Death Valley, historically one of the hottest places on Earth, 125 degrees. I will point out that these temperatures were what were inside the Skylab 50 years ago before it was rescued with a parasol shade by the first crew to occupy it that just came back. So these were hot experience 50 years ago in Skylab till they made that repair. The second crewed mission is launched in July 28th in 1973. So we'll be celebrating that with Jack Lausma being the crew member that's alive from that, a good friend of ours. So yeah, I even see the temperatures. It makes me want to wave my fan, Marty. So where does the phrase dog days come from? All right. Let's get to that. The dog days of summer are hot, sultry days of summer, usually between July 3rd to August 11th. They were historically the period following the heliacal rising of the star system Sirius, which astrology connected with heat, drought, sudden storms, lethargy, fever, mad dogs, and bad luck. Well, the star Sirius is the brightest star in the sky. You see it in the wintertime. It is called the dog star because it's the brightest star in the constellation Canis Major, the big dog. We'll talk more about that in a second. These painstakingly hot summer days get their name from an ancient belief that the brightest star in the sky, Sirius, was adding more heat to the Earth because Sirius right now is in the daytime sky. You can't see it, but Orion would be high in the sky around noon instead of high in our sky during midwinter. For many dog days evoke the summer days that are so devastatingly hot that even dogs would lie around the asphalt panting, okay? And that takes a lot to knock a dog down from all that. So throughout ancient history has been all kinds of thinking about this, and literature's filled with it. One of the comments here from the 1830s is the dog days are a time when the sea boiled, wine turned sour, dogs grew mad, warriors raged with anger, and all other creatures became languid, causing man, among other diseases, burning fevers, hysterics, and frenzies. I've had some of those frenzies, Marty, particularly when I've been mowing the yard lately without a hat, which is stupid to do. And then I put the hat on inside, or once I go back out again, suffering a little bit of heat stroke. But boy, have you got to be careful with yourself, particularly us senior citizens. So, but of all ages, there's all kinds of things to do. But again, the reason for the dog days of summer is from our northern hemisphere. The sun is higher in the sky. All right, the rays are more direct, and that creates more intense heat than the longer rays spread out over more area. Keep in mind that our good friends down under are experiencing their days of winter down there, like Cliff Watson in Pomona, Australia there. So the British husbandman's practice in 1729 claimed that heat stroke is so violent that men's bodies at midnight sweat as at midday. And if they be hurt, they are more sick than any other time. All right. And it also advised men to abstain from women during the dog days of summer and take heed of eating too quickly, as it says here, feeding violently. All right. So some of the places that, well, let's look at some of the myths around the dog days of summer. Take a cold shower and calm you down. That's a myth. The cold water just makes your body want to work harder to warm it up. Avoid exercise. That's a myth, isn't it, Marty? You're an exercise person. You just have to stay hydrated and do shorter sessions, maybe more reps, less reps, more, less.
Just less.
Just at rest. And reps.
No, I'm saying just less of everything.
Oh, less of everything. Yeah, right. Eat a curry food, hot curry. Well, that is a fact. That can help your body cool down. How about sleep naked? Nope. Actually, your cotton pajamas wick the heat and sweat off of your body to keep your skin cooler. So don't sleeping naked's not going to cool you off anymore. All right. Some of the other things that are talked about that you might be interested in. Dog days were mentioned in Richard Adams's 1972 novel Watership Down. Diary of a Wimpy Kid series talks about dog days. There's a great movie, Dog Day Afternoon, that evoked the oppressive seasonal settings of the summer. There's some music. You've got Dog Days by Within Temptations in 2013. Dog days are promoted commonly in baseball stadiums, particularly the minor league stadiums, where they use American ballparks to boost ticket sales with cool ice cones and ice cream deals and stuff like that at the old ballpark. So there's a few things about it as we look at a dog there chilling out the best way. In Western medicine, bloodletting and induced vomiting should be avoided during dog days because the sun is in Leo, and that'll and whatever the thinking of was about that in astrology. So the Romans are the big culprits of why we actually think of this as the dog days, as well as the Egyptians. The Egyptians had their sun god Ra, and they were very tuned in to Sirius, the dog star, that would rise when the Nile flooded. Okay, so that was a very important, when they saw it rising in the morning sky, that was going to be flood time or springtime. And so now, if you could take the sky right now, turn off the sun, the light, you would see the winter constellations in the sky. And that's where all this started. The Egyptians and the Romans big into the dog days. The Romans blamed Sirius for the heat of the season and the lethargy and diseases that happened to go on. It just makes sense. People would overdo themselves, sweat violently, throw up, that sort of thing, all the signs of heat stroke. Seneca's Oedipus complains the scorching dog stars fires, all right? And so here is Sirius, the culprit behind all this, and really promoted by the Romans more than any other culture. The dog star is the brightest star in the sky. It actually has another star orbiting it that's very hard to see even with a telescope in your backyard because Sirius is so bright. Now the planet Venus right now is much brighter than Sirius. Planet Jupiter is always brighter than Sirius. Okay, Sirius is a negative magnitude magnitude star. And here it is in the constellation Canis Major, outlined as a stick figure of a man. All right, with his head is Sirius up there, and in the there is again how the dog is played out in the mythology of the stars up there. And this, of course, looks nothing like a dog, Marty. It looks like a stick man, if it looks like anything. But the ancients had great imagination and invented this mythology around that. As I go. So there's Orion in relation to Canis Major and Canis Minor, with Sirius as the bright star, and then Procyon is the bright star of Canis Minor. All right, and they form with Betelgeuse up there, the armpit of the giant, the winter triangle of three stars. You can see how there. But the Orion, the mighty hunter, has his dogs with him, and because Canis Major is the brightest star in the sky, they didn't understand 5,000 years ago that what created the brightness. They thought that there's heat associated with it. So they definitely thought that Sirius was adding to the heat on the Earth because they thought that the sun went around the Earth also. All right, these ancients that came up with the dog star did not have the modern theories. It's a fact now, proven just over 400 years ago, that the sun is the center of the solar system and the Earth orbits it, not vice versa. There we go with beautiful Sirius again and the dog days of summer. So, Marty, any questions anyone have about the dog days of summer there, or comments? Or do you have a question, sir?
Nope.
No?
Nope.
Okay.
No.
Well, sure is hot enough, and that sure is an explanation. So take care of your dogs, cats, squirrels, whatever you're taking care of there, Carlton Bailey. And it's a serious heat we have, whatever causes it. No need to argue about that. Let's deal with it. So, of course, inflation, electric bills, highest ever, that sort of thing, just adds to our whole attitude of feeling bad in the heat of the summertime. And there's a beautiful sky view there. Well, in our Space View Park, we have the Apollo Monument there that one night I took the moon rising between the A there that has the Earth and the moon and interlocked by the 135 steps that have to go right on an Apollo mission from launch to landing. If one of those 135 things failed, the mission would have to be aborted at some point in time. And that's what we're talking about, encouraging you to go check out Apollo 11 live. They're orbiting the moon right now. They'll be going to sleep here in a little bit, but you'll hear mission control, you'll hear the astronauts talk, and then the busy day tomorrow when they start getting ready after the landing at about 5:30 in the afternoon tomorrow. So we'll be talking about that tomorrow. Well, this is the scene about 7:55, quarter till 8, depending on what latitude you live in. This is actually from a high latitude in England is where this is set. Well, the landscape is. But right after sunset, you'll see Venus in the twilight, and you'll see the crescent moon is 2 days old. New moon was 2 days ago, so we call the crescent moon 2 days old. It's going to be a thin fingernail, all right? Above Venus will be the star Regulus in Leo the Lion, and Mars is above it, and Mercury is going to be skirting the horizon. But by 8:30, this will all be gone. But so Venus is putting on quite a show. It's the brightest it ever gets, almost -4 magnitude, all right? That's super bright. Mercury's about a -1 magnitude. Mars is only second magnitude, very faint. All right, where Mars was almost as bright as Venus last October because it was only 40 million miles away from Earth. Now it's almost 200 million miles away from Earth. You got to consider these things when you're talking about human exploration of Mars. The other thing you got to consider is in a short 2 weeks, Mars is going to be behind the sun and out of communication with the Earth, and we won't have communications for about 2 weeks until Mars orbit takes it on the other side of the sun and it pops up in the morning sky. Now, from where Mars is at, it can see the other side of the sun that we can't see. It can see the backside. So imagine Venus is between the Earth and the sun right now, but Mars actually has the sun between the Earth and it. So, all right. Hope you get out and check that out. Let's talk a little bit about how Venus changes and Mars changes as it increases distance. Because Venus is closest to Earth, it is a crescent. Most of the light is being blocked from it, all right? And so it is a very thin crescent, yet is super bright because of those reflective clouds. If we didn't have clouds around Venus, we would be talking about its surface all the time because it always looks pretty big, as you can see in March. That's about as small as it gets at gibbous phase. And then it goes through phases like the moon because it's between us and the Earth. And then it will drop down behind the sun, go in front of the sun actually. It'll go a little above the sun. When it goes in front of the sun, that's a transit, and that only happens twice a century. All right. But it'll go above the sun, and then we'll see it in the, not see it for a few days because it'll be in the daylight. And then when the sun rises one morning, you early sunrisers here in a month are going to see a bright star, and that will be planet Venus. Now, Mars, on the other hand, in January, had just gotten done with opposition, and you could still see features on Mars. But look at it 6 months later, you can barely tell that it is a disk with the same kind of power. And the power we're talking about here in a telescope is around 200 magnification, all right? So Mars is pathetically small and far away. You can just barely tell it's red and that it's a disk. As we're in January and back in October, it was about it's about the size of what we see June 12th there for Venus in the middle. Mars got that big in October, and now it's just puny. I thought this is an interesting visual to show everybody. These are facts, all right? We knew that Mars, 3 billion years ago, in our 4.5 billion year history of our solar system, Mars looked like that then, covered with water, all right? Now it's a desert, it's a barren desert as cold as Antarctica on a warm day. Venus, same thing. Venus, billions of years ago, we're talking at least 2 billion years ago, we know had water and oceans and lakes and probably rivers and everything associated with that, maybe even life. And today Venus is Earth's hellish twin. It is 900 degrees on the surface of Venus. A average day on Mars at the surface is like 20 degrees, all right, just above freezing. Where Venus is 900 degrees surface. What happened to these two worlds that they changed so drastically in a long geologic time? 2 billion years is a very long time. And Earth, 2 billion years ago, was an inferno of lava, volcanoes, continents being formed, no water, and now we're 70% water, all right? This is why we explore. This is why man has this innate curiosity to find out where we came from so we can predict where we're going. But here's a striking example that Mars and Venus may have been lush, habitable worlds 2 billion years ago where the Earth wasn't, and now the roles are reversed. We don't know what happened or why, but this is the science and engineering and physics and planetary geology are all big fields now to try to understand these things. there's a picture of Venus they took last time it had a big crescent there. Hadn't had a chance to get out and photograph it this time because of all the afternoon storms going on. Let me get a drink there. But it does look like a crescent phase. Reflects like a mirror because of those clouds on it. Underneath, the U.S. hasn't landed there, but Russia has. And this is one of their probes, the Venera probe that landed in the 1980s. This is a very cleaned up picture of it, showing you distant mountain ranges there. That artifact in the middle there, that metal, that's the cover off of the camera that was popped off. On the left is a sensor that basically just pounded on the rock to get a tensile strength. 900 degrees, the vehicle was crushed by the atmosphere that's 90 times stronger than Earth because of 30 miles of atmospheric layer that's just like weight on top of you. All right. And the vehicle lasted for about an hour and a half before the heat and the crushing atmospheric pressure took this. But look at the flat rocks. Very desolate, strewn scene there. And Venus, covered in clouds, the sunlight bounces all around it and creates like an amber yellowish glow, even on the back side, where it should be dark, but it's more like twilight. Of course, can't talk about Venus without talking about the belt of Venus. The belt of Venus, you'll see it on a nice sunset evening. Look opposite the sun in the east, the sun sets in the west, then look, so have your back and you'll see the cloud bands coming up is the shadow of the earth. That dark band is the shadow of the earth, and the pink is called the belt of Venus. It's the atmosphere scattering of light in there, and it's named after Venus, the goddess Venus, not the planet Venus, because a belt in goddess Venus's times was a woman's brassiere. So the belt of Venus literally is girdling our horizon as you see it. And some days it's really pinkish and peachy, and other days it's hard to see. But once again, the dark you see below there, that's the Earth's shadow projected into the bright sky there. So, all right, we want to just end you a little bit with the sun. And of course, our disclaimer, do not look at the sun with any optical instrument, no matter how powerful, binoculars, telescope, no, hunting rifle, no. But this is the sun today. It's got these giant spots on it that are naked eye. If the sun sets and it's in a bunch of clouds and you can look at it, you know, safely, that's okay the last 10 minutes, 15 minutes as it's setting. Or a number 14 welder's glass. If you have any welders in the family, that welder's helmet can look and see the sun. But isn't that amazing that you see the granulation, which is like oatmeal boiling? It's about 1 million miles across our sun, 800,000 miles. So it's actually brighter in the middle, and the edges, as you see, are not, they're a little less bright because that is 250,000 miles further from the Earth in our line of sight than the center is, if it's 1 million miles across there. So that's all about the inverse square law of light, diminishing the brightness of it. Well, how could we see the backside of the sun to know what's going on? Well, sometimes we have some solar dynamic observatory that looks at the sun is on the backside of the sun. It's not right now, but this is a question posed by the way, these sunspots do create electromagnetic disturbance in the Earth's things that we're using electronically, all right? Also, the aurora borealis and australis in the south are caused by particles coming off these cooler areas of the sun where magnetic energy patterns are actually crossing and cooling this area of the sun. We don't really understand it that well, but we do understand it enough to know that the far side of the sun is invisible by the Earth by definition, okay? But we have two different ways of seeing it. Now, this is from my homepage website, which is called spaceweather.com. Well, one way that we can see what's happening on the backside of the sun is called helioseismology, researchers have learned to monitor vibrations on the sun. Far side vibrations, sunspots affect these vibrations and reveal themselves by their helioseismic echoes. They look like big dark blobs, and you can see the pointing there of the big dark blobs. Shown above are the results for July 18th. There are currently 2 large sunspots on the far side. Spot number 2 is of particular interest, all right? Well, one other way that we do it is look from Mars, all right? This is the view in the center from Perseverance, our rover on Mars. And you can look at every picture in raw format taken on the surface of Mars because U.S. taxpayers paid for it, and they post them up there every day. And this is a screen grab of just a section of that where it's showing you some of the harvesting, some out of the scoop, some Mars soil. You've got some other maybe engineering pictures there to guide it driving. And then the black with the dot in the center of it, it always takes a picture of the sun. Perseverance does, and so does Curiosity. That's been on Mars roving for over 12 years. Why do they do that? Because they gauge how the brightness of it, and if it starts to dim, they know that there's dust in the air on Mars and that a dust storm could be happening, which does happen very frequently on Mars and actually shut down the rover opportunity because of its solar panels got starved. But those are the images there that it takes every day of the sun to check the opacity of the atmosphere, and there's an enlargement of it. And there's actually 3 sunspot groups that you can see with this very low resolution camera on Perseverance. Well, thank you, everybody. We got a meme there. I see Melissa Pope's name's up there. Jamie Orange, I don't think your name's up there. Larry Pushkar. Dave Stange, Carlton Bailey, and a host of others there. Robert Law, Doug Forrest, Melissa Pope. You see your names up there. We're so grateful that you take your time to watch Stay Curious. Keith Sewell, still traveling around the country. Keith will bop in here one day, Marty. He used to be our astronomy educator at the American Space Museum. So, yes, we are grateful that you're with us here. And I'm grateful for air conditioning. I'm grateful for my hat and sunglasses and my drink here as we take you out today on Stay Curious. And just to say to you all, stay cool out there, okay? And I love dachshunds. That reminds me of my dachshund Beanie Weenie. And I could pose him like that in a heartbeat, Marty. But anyway, stay calm and cool and collected. My temperature might get a little on the touchy side from time to time as I'm out in the heat, so I'll watch that also as we all be kind to each other, particularly in traffic. So, Marty, great Streamlabs job again today, and thank you, sir, for getting us on the moon again, all right? We'll be at the Italian American Club with eating a great lasagna dinner tonight and hearing Marty Winkle and Roger Visioli tell some tales about building the lunar modules that are still the only vehicle made to operate in the vacuum of space by 2 astronauts standing up, all right, and only operate in the vacuum of space and be able to lift off an alien world. Cheers to that, Marty. Thank you all. Until tomorrow when we do Apollo 11 wall to wall, and you're going to learn some things, I guarantee you. Stay curious. I'm Marquette saying I can't wait to bridge the space between us.